Hello, welcome to our third distance lesson in physical science. Today we're going to look at weight and the force of gravity. So our learning target is learn the physics definition of weight and how weight is different when the force of gravity is different. So the physics definition of weight, like many physics definitions, is a little bit different, I think, than what we are used to thinking of as weight. And it turns out that weight, the force of gravity, is part of weight, or the acceleration of gravity is part of weight. And so if we could go someplace where gravity is different, like another planet, then we would find that the weight was different. So we've seen that gravity makes objects accelerate. Gravity is a force, and forces cause acceleration. So gravity can speed up a falling object or an object rolling down a slope. If something is fired or shot into the air, gravity slows it down, accelerates its negative acceleration first, and then it accelerates it downward. So a force is a push or a pull. So gravity is a force. Gravity pulls on everything on Earth. It pulls it towards the center of the Earth, what physicists call the center of mass of the Earth. Weight is not the same as mass. So we've used mass a lot like it was weight, but mass is the amount of matter in something. Weight is the force of gravity on an object. It is written F with a little subscript G. The little g is for gravity. All right, so if you were orbiting the Earth, you would have no weight. You'd be weightless, but you would still have all your mass. And we'll talk more about mass in a little bit, a couple of days when we start talking about inertia. All right, so weight is a force. The more mass, the stronger the force. The equation for weight is this. Fg, that's the weight of something, or the force of gravity acting on something, is equal to the mass of the object times g. G is that acceleration of gravity, which we saw the other day, and it's 9.8 meters per second squared. So again, F sub g, it's written as an F because we use capital F for forces. Weight is the force of gravity acting on something. Weight is a force, and it's equal to your mass times the acceleration of gravity. This is just about units. If we're measuring mass in kilograms and we multiply it by acceleration in meters per second squared, we get newtons. And the symbol for Newton is capital N, and that's the unit of force. So the force of gravity on a 100 kilogram person, that's about 220 pounds, is 100 kilograms times 9.8 meters per second squared, and that's equal to 980 newtons. All right, think about the moon. The moon has weaker gravity than the Earth. If you could go to the moon, would your mass be different? No, because mass is the amount of matter in something. You would still be you would still have all your matter, your mass would be the same. But would your weight be different? Your weight would be different, yes. Your weight on the moon would be the force of gravity acting on your mass, and the moon's gravity is not the same as Earth's. It's weaker because the moon has less mass. So the force of the weaker gravity on your mass would be less. Watch this video from 1972 of an astronaut bunny hopping in the weak gravity of the moon. Check out his hang time. This is a full speed video. This is not slow motion. Oops, that didn't work.
Boy, when you do this and you go down slope, that first step is a long one. I'm having. This is the best way for me to travel, uphill or downhill. But that, like this, two-legged hop, and on level ground I can skip. I don't like that loping thing. Oh, the loping's the only way to go. Checkpoint. See, when I'm on level ground, I can skip. But this two-legged thing is great. Yeah, I covered ground like a kangaroo.
All right, so the astronauts had kind of a hard time getting around. They had very restrictive spacesuits, but fortunately, the very slight gravity of the moon, which is only about 1/6 as strong as Earth's gravity, enabled them to hop to get from place to place. All right, so the weight, your weight on the moon, the force of gravity acting on anything on the moon, is mass times the gravity of the acceleration of gravity on the moon. So g on the moon, the acceleration of gravity on the moon, is only 1.6 times as much. That's about 1/6 as g on Earth. Your weight on the moon would be only about 0.16 or 1/6 as much as your weight on Earth. Gravity, like all forces, is a vector. Its direction is down towards the middle of the Earth or the middle of the moon if you're on the moon. Why is gravity different on the moon and planets? Gravity is a force between the masses of two objects. The more mass, the stronger the force. So gravity on Earth is actually attraction to the Earth's mass. The Earth has a lot more mass than the moon. Gravity on the moon is attraction to the moon's mass, which is much less. So the force of gravity acting on mass is weight. On the moon, the force is less, so the weight of anything is less. And here's a little chart showing mass of gravity on the moon and planets. I didn't realize that my image was going to cover up part of this, but you can see a little bit. The moon has a mass that is 0.13 as much as the mass of the Earth. That's only 13% as much mass as Earth. And the acceleration due to gravity is about 1.6 meters per second compared to not quite 10 meters per second squared, not quite 10 meters per second squared on Earth. So again, the acceleration of gravity on the moon is 1/6 on Earth. Mars has more mass than the moon, not as much as Earth. It's got about half as much mass as Earth. And the acceleration due to gravity on Mars is about 3.7 meters per second squared. Jupiter is a big, massive planet. They call it a gas giant. It's 318 times as much mass as the Earth. The acceleration of gravity is about 24.5, I think, meters per second squared. So not quite 3 times as strong as it is here. You would not be bunny hopping on Jupiter. And Neptune is about 17 times as massive as Earth. The acceleration of gravity is about 11.2 meters per second squared. It's a little bit stronger than Earth. Remember, Earth's is about 10, not quite 10 meters per second squared. The reason it can have all this much more mass and the acceleration of gravity is only a little bit more is because Earth is a lot more dense. These big planets are called gas giants. They're made up mostly of gas. You don't need to remember that. All right, so returning to our learning target, the physics definition of weight and how weight is different when the force of gravity is different. All right, weight is defined as the force of gravity acting on an object. It's written capital F because it's a force with a little subscript g to let you know it's gravity, and it is equal to the mass of something times the force of gravity acting on it. It's the mass of something times the force of gravity. Weight is different if the force of gravity is different, such as on other planets. Thanks, and have a good day.